Hello, my name is Peter Ragaert, Director of the organization Pack for Food, and I would like to give you insights into the exciting world of sustainable food packaging. I want to thank my colleague Hedwige Verherrugghen, Project Manager at Pack for Food and taking the lead in the Pack for Food activities within the FAIRCHAIN project, for her input as well in this presentation. Throughout this presentation, I would like to focus on four main parts. After an introduction into food packaging, we will focus on the current available packaging materials and their properties. This is followed by the specific Belgian case within FAIRCHAIN, which focused on stand-up pouches as packaging materials filled in an innovative filling system. We conclude this tutorial with future opportunities related to this case, as well as further challenges within sustainable food packaging. In this introduction, I would like to briefly introduce our organization Pack for Food, and after that, go through the different functions of food packaging. Pack for Food is an organization bringing together all stakeholders involved in food packaging and connecting them with research institutes. Our focus is on 5 main activities. Amongst others are initiating and coordinating research projects, giving trainings, providing customized advice, and last but certainly not least, organizing different network activities. On this slide here, you can see an overview of the members of Pack for Food at this moment. These are both small, medium-sized, and large companies representing in fact the complete value chain of food packaging. This is from packaging converters over producers of filling systems, as well as providers of testing systems, companies that are in fact using the packaging materials, being the food producers, also the retailers are involved, and as well the companies within sorting and recycling activities. Now, let's take a deeper look into the 4 main functions of food packaging. So why are we in fact packing food products? The first one is about protection. This is in fact the most important one. It is about preventing changes related with physical, chemical, or biological processes. Think about preventing discoloration of food products. Think about preventing oxidation of food products or slowing down microbiological processes. The second function is about containment. Containment means that we need to find a way to transport packages from one place to another place. It's about preventing pollution of food products. It's about preventing product losses. So it needs to enable the storage, the transport and distribution throughout the supply chain. The third function of food packaging is convenience. That means offering through innovative containment solutions, like for example, easy to open packages, reclosable packages, but as well portion-sized packages. The fourth and last function of food packaging is also a very important one. This is about communication, providing the required information, for example, in terms of ingredients in the food products, allergens in the food product, but as well as providing information, for example, how to prepare the food products. And last but certainly not least, also from a marketing point of view, communication, of course, through the packaging is very important. Through the packaging design, through the printing, you in fact want to stimulate consumers to buy the packaging. After this introduction on functions of food packaging, we can go to the following section. In this next section of the tutorial, we will focus on the most currently used packaging materials for food packaging and their related properties. Basically, within food packaging, you have 4 main materials. The first one are the metal-based packaging materials, being mostly aluminium or steel-based. The second main use material is glass packaging, which is in fact based on sand in fact as resource. The third main material is paper, paperboard and cardboard, which is fiber-based coming from wood. And lastly, we also have plastics, and most of the plastics nowadays are based on crude oil. Every of those packaging materials has its advantages and also its disadvantages. There is in fact no perfect solution. In this slide, in fact, we will show you already some important considerations that you need to take when you want to select a certain packaging material. The first one is about the origin and the location of resources. Are these resources coming from a local places or more from a global perspective? A second main consideration are the processing conditions, both to produce the packaging materials, but as well to process them after they have been used. Think, for example, about the high temperatures needed to produce glass or metal packaging. Or think about the large amount of water needed to produce paperboard or paper-based packaging. Or think, for example, about different types of multi-layered plastics, which are frequently used for food packaging and which are difficult to recycle. The third important consideration in this slide is the weight of the packaging, which can have a huge impact on the transport and the related environmental impact of that. Think, for example, about the difference in weight between glass-based packaging and, for example, plastic-based packaging. Besides these considerations, other aspects also need to be taken into account, starting with the gas and water vapor barrier properties. Now, before going into those gas and water vapor barrier properties, I would like to show you in this slide the three main interactions that can take place between the packaging material, the environment, and the food product. The first one is related to those gas and water vapor barrier properties. It has to do, in fact, with the permeability. That means the exchange of gases and other volatile components from one side to another side of the packaging material. A second interaction is about migration. It's in fact a transfer of components from the packaging material into the food product. And this is, of course, strongly regulated with legislation because this has an impact on food safety. And lastly, we also have scalping. Scalping is in fact the transfer of components from the food product into the packaging material. And this is, of course, a very important point to consider for recycling companies, as these absorbed components need to be removed before the packaging can be used again as recycled material. Now, let's dive now a little more deeper into the permeability aspects. In this slide, we see here the two main important parameters to consider when talking about permeability. We have on the one hand the oxygen transmission rate, which indicates how much oxygen is going through the packaging, and on the other hand we also have the water vapor transmission rate. Now, this OTR and WVTR is depending on different factors, starting with the type of material. If we look, for example, to glass and metal, these are in fact the perfect materials in terms of gas and water vapor barrier. In case you have a thickness of more than 25 micrometer, these materials are in fact completely impermeable for gases and for water vapor. Another profile in the OTR and WVTR can be seen in paper and paperboard. Because of their structure, their internal structure, they have a very high permeability. A strategy to reduce this high permeability is by applying coatings on paper or paperboard. In this slide, you see different types of coatings that can be used to reduce the permeability. You, for example, can use conventional plastics which are currently used as coating, like low-density polyethylene, LDPE, or, for example, polyethylene terephthalate, PET. Another interesting coating is PBAT, which is a coating. It's crude oil based, but it is home compostable. So in the end, if you coat this on paperboard, for example, you have a completely compostable material. Next to that, you also have other coatings, as you can see, like for example, acrylic-based coatings, bio-based coatings, like for example, polylactic acid, as well as waxes. The last group I would like to discuss with regard to oxygen and water vapor transmission rate are plastics. Plastics are characterized by a different range of permeabilities depending on the type of plastic. For example, polyethylene has a very high oxygen permeability, while PET has a much lower oxygen permeability. To customize barrier properties to achieve specific values for OTR and WVTR, multilayers are often produced and are widely available. In this table, you can see different examples of plastics currently used for food packaging. This table contains both monolayer plastic materials as well as multi-layer plastics materials. And I want to focus specifically on two examples. The first example, which is indicated in this table, is an example containing an EVOH layer. EVOH, which stands for ethylene vinyl alcohol, is a plastic layer specifically used for its very good gas barrier properties, which you can see very good in the table. If you look to the column with the oxygen transmission rate, this value is decreased a lot by including EVOH. Another interesting point here in the table is the last line, which is a PET layer coated with silicium oxide. This is a quite new gas barrier material, which is very thin, and therefore, in fact, this whole system is also recyclable. Besides these important gas and water vapor barrier properties, some other parameters are also important in selecting the most appropriate packaging material. Leak integrity is also an important property to consider. This is about closing the packaging properly due to sealing processes or to capping processes. And of course, this leak integrity needs to be there the whole shelf life of the packaged food products. Leak integrity is also partly related to the mechanical properties of the packaging material. This means the strength of the packaging material. For example, during transport, we need to make sure that the packaging can withstand the transport. Think about vibrations and so on. Furthermore, the selected packaging material also needs to be compatible with, let's say, environmental factors, the first one being the filling machine. Filling machines nowadays are running at very high speeds. The speed of the line is dependent on the type of the packaging material that is used. For example, a plastic film will have a different behavior compared to a paper-based film on a packaging line. After being filled in the package and closed properly, the package is in fact ready to be put in the logistics chain. There are a few exemptions. For example, when the closed packaging needs to undergo a post-pasteurization or post-sterilization step, but in general, packing food products is in fact one of the last steps before the packaging is entering the logistics chain. And this is in fact also a very important point to consider. What about stackability of packaging materials, vibration resistance, and so on? Finally, another important factor to take into account is the compliance with legislation. There is quite a lot of legislation on food packaging, and in general there are two main groups. On the one hand, you have legislation which is in fact taking care about the food safety of food contact materials and thus as well food packaging. On the other hand, there is also legislation on sustainability of food packaging. Think, for example, about the new packaging and packaging waste regulation. This last one will have a major influence within the selection of packaging materials to be used for food packaging. It can in fact therefore be seen from this slide that multiple factors need to be taken into account when you want to switch to alternative packaging materials. Let's now take a deeper look specifically for the Belgian case within the FAIRCHAIN project. Within this Belgian case, the focus was on the plastic stand-up pouches as packaging materials filled in an aseptic filling machine. Stand-up pouches are materials which are already many years on the market, but they show different advantages. First of all, they have limited transport space. They are provided flat and then they can be filled. So they don't need a lot of transport space to the filling company. Secondly, they are easy to fill and also easy to close. In this case, with a spouted stand-up pouch, it's easy to open and close the cap. Next to that, because of the fact that it is a plastic-based material, it is very light in weight. It's also convenient to use and very important, there is a minimal risk of food waste, as because of the structure of the material, you can really squeeze out the last droplet or in general content of the packaging. Another important part is the branding. There is quite a lot of surface to brand your product. And last but certainly not least, we also have a customizable material, for example, in terms of barrier properties. You can play with the composition of the packaging material to give the exact amount of mechanical or barrier properties. Now, these stand-up pouches should of course be compatible with the complete filling system, where we have to take into account three main factors. The first factor is about the food product itself. The food product needs to be pre-stabilized, for example by pasteurization or sterilization. The second main important factor is the packaging material itself, because this needs to be decontaminated before it can also enter the packaging machine. And thirdly, the environment in which the packaging takes place, the filling takes place, needs to be aseptic. And it's these combinations that make sure you get a very stable packaged food product. Within these requirements, the FAIRCHAIN filling system has two main features, which are beneficial for, on the one hand, the direct farm-to-fork stakeholders, as well as for industrial stakeholders. In this slide, you see the two scenarios. For small-sized companies, there is no need to have a complete room which is completely aseptic, because the filling machine itself contains a sterile zone. So the machine can be placed in an environment which is non-sterile. For the large players, this innovative filling system allows to eliminate after-pack sterilization. In the previous section, we presented different requirements for food packaging materials. Let's now specifically look which requirements are needed in the case of the stand-up pouches within FAIRCHAIN. Let's again start first with the two very important parameters being oxygen and water vapor transmission rate. The products specifically focused within this case are on the one hand applesauce and on the other hand cheese sauce. As you can see in this slide, these are products with very long shelf lives. Based on data found in literature, the maximum oxygen transmission rate is 2.5 ml oxygen per square meter per day. And for the water vapor transmission rate, this is maximally 1 gram water vapor per square meter per day. Besides these barrier requirements, we should also take into account other requirements related to the filling system. For example, what about the filling temperature? When you do an aseptic filling, normally this is at cold temperatures. But it could also be convenient to have hot filling processes in that filling machine as well. When we go specifically for aseptic packaging, the packaging material itself, so in this case the stand-up pouches, should be resistant to the used decontamination products. Next, the packaging design should be compatible with the filling equipment. For example, in the case of this filling machine, the spout is needed to bring the pouch, in fact, into the filling machine. These were the requirements directly related with the product packaging filling system. However, also other criteria need to be taken into account. A very important one is the one related with the legal perspective. All packages on the European market need to be 100% recyclable by 2030. Another important factor is that we should be able to supply smaller batches for the more small-sized actors. Besides, the packaging costs should be also manageable and should also be a good way to brand the product. Now, as stated before, for stand-up pouches, branding is quite easy to do. With regard to the consumer, the material should also be easy to use and easy to be emptied as well as to be reclosed. Taking into account all the different requirements, a packaging configuration for stand-up pouches has been selected in this case. Specifically, we have selected a stand-up pouch made out of polyethylene with a small layer of EVOH. This EVOH is needed to provide enough barrier properties to the packaging material. The spout is also made out of polyethylene. Overall, this composition on the one hand fulfills the functionality that it needs, but on the other hand fulfills as well the design for recycling guidelines, which need to be taken into account to make sure that we have a 100% recyclable material. For the guidelines, we can refer, for example, to different tools which are available online, like for example the Recyclas tool or Saflex. So in the end, we have a configuration which is polyethylene based with a limited amount of EVOH as gas barrier layer in the middle layer, fulfilling the latest design for recycling guidelines. Besides this composition, we can also say that this material is available because different European-based producers are producing currently the so-called high barrier polyethylene. These stand-up pouches make it also possible to do late product identification. For example, if a larger batch of the same pouch need to be made, this can be supplied to different farmers and each of the farmers can apply a specific label on that. Specifically for the label, it's important to also have the polyethylene as material for the label because then you maintain the 100% recyclability. It's also important then, related with the last points on product identification, that this system now allows that different actors can use the same type of pouch. For example, in the case we have a cooperative. Let's move on now to the last section of this tutorial, focusing on future opportunities and challenges. In this section, we are going to elaborate on the one hand on the European policy framework regarding food packaging, and on the other hand on the link of FAIRCHAIN with other European or national projects. With regards to the legislation, we have on the one hand the Circular Economy Action Plan of the European Commission. This has led already to different types of legislation. For example, the Single-Use Plastics Directive in 2019. Or for example, in 2020, there has been legislation on the contribution of every member state to pay a certain fee for the non-recycled plastic packaging fraction. And more recently, there is a proposal of the Packaging and Packaging Waste Regulation, which is almost finished. The focus within the European policy regarding food packaging and packaging in general is on the three words being reduce, reuse and recycle. On the other hand, there is also legislation regarding food contact materials and their food safety. This will also change significantly in the coming years. Think, for example, about new regulation on food contact materials like plastic food packaging. There has been already in place new legislation on recycled plastics and new recycling technologies for food contact materials. And in future, there will also be legislation to be expected on reusable food packaging, for example, protocols on hygiene levels of reusable packaging. Specifically for the stand-up pouches and its related filling equipment, we are currently focusing on 100% recyclable stand-up pouches, as this is really one of the focuses in the proposal of the Packaging and Packaging Waste Regulation. Now, in future, we can also think about adding bio-based content, for example, bio-based polyethylene, to be included in these pouches, as to further move away from fossil-based resources. Next to the spouted stand-up pouches currently in scope of the Belgian case in FAIRCHAIN, we could look to the non-spouted alternatives, so where the pouch is in fact sealed, as these represent an important part of the stand-up pouches market. This also opens options for packing food products with particles, for example, pieces of fruits or vegetables. Furthermore, such pouches can also feature reclosability through, for example, zipper solutions. In relation to the upcoming Packaging and Packaging Waste Regulation, other opportunities to look into for future applications are reusable packages, to be filled with this same filling machine. We can think here, for example, about plastic-based or glass-based bottles. And another interesting point to further elaborate on is the implementation of mobile filling equipments, allowing different farmers to make use of this innovative filling system. FAIRCHAIN is of course not a standalone project, and there are quite a lot of interactions with other projects and a lot of possible collaborations with other projects. We can name here Value for Pack, which is an I3 project stimulating innovation and investments in sustainable food packaging through connecting different European regions. Another European project is a project called FOX, and it's about the implementation of mobile food processing solutions. Tactic is a project coordinated by Pack4Food together with Flanders Food, and it aims to give an overview of supporting tools to communicate on sustainability of food packaging to customers and to consumers. With this tutorial, we hope that you have gained more insights into sustainable food packaging and that you are excited about the newly developed food packaging systems within the Belgian case of FAIRCHAIN. We hope to meet you soon to further discuss on this topic and explore collaborations.